Let's talk about how to get started when you're designing a bent part. First thing we want to do is, of course, start a new file. We're going to do a part inch file, and inside here, you'll notice on the tabs that we have a weldments tab. Well, this might not be displayed by default, so if you right click, you can have weldments and sheet metal. Now, these are two very different sections, but they can be used together. First, we're going to start talking about sheet metal parts, and there are two main ways that you can start a sheet metal part. You can either create some sort of base. Now, this is going to be the base where you have a flat section and bent parts are going to start to come off of it. Now, in SolidWorks, when you're designing your sheet metal parts, you design them as formed or as bent. Then you can flatten them out and make sure that everything works how you expect it. And then you can ultimately end up with a flat pattern that you send off to be water jet or laser cut, stamped, whatever the case is. And that's how you get the end result for your bent part. But there is another method to creating these bent parts. And it's one that's actually really powerful and I don't think a whole lot of people use. And that's the second option that says convert to sheet metal. Now inside SolidWorks, you have the available option to make a solid body and you can turn the outside edges of it into a bent sheet metal part. So let's take a look at this quick convert to sheet metal tool before we actually get into creating our own bent parts. So I'm going to start by creating a sketch on my top plane, and I'm just going to do a center point rectangle at the origin that's 4 inches tall and 6 inches wide. I'm then going to go to my Features tab, and I'm going to extrude this up 1 inch. I'm also going to go ahead and draft it outward 10 degrees. Now from this face, let's go ahead and sketch. We're going to use Convert Entities, and we're going to say OK. Now we're going to extrude this one up 2 inches with no draft. So currently, you see that we have just a solid body here. We have a flat face on the bottom. We have some edges that have a draft on them. And then we have this section up top that has no draft. So what we want to do is go to our sheet metal tab and go to convert to sheet metal. Now this is a very handy process and there are just a few things that you need to understand. First, we're not going to talk about gauge tables. It's really more of an advanced section talking about bent parts. But you do need to understand the different ways that gauge tables or different values affect how your parts are created. We'll talk about that a little bit more when we get into our sheet metal examples. The first selection that you need to do is select a fixed entity. In our case, I want to select this bottom face. That was the first sketch that we created. Next, you'll notice that by default, it brings in a sheet thickness value. Now, obviously, this is way too big, so we're going to change this value to 0.05. You notice that we have options to reverse thickness and also keep the solid body. So these can be very handy options depending on whether or not you're drawing the inside edge of something that a surface or a sheet metal part needs to touch, or if it's an outside edge. Now, if we zoom in a little bit, you can see a preview of where the sheet metal actually is. If we reverse the thickness, it goes to the outside. Let's go ahead and zoom back out and move on. You'll notice that the next dialog box here is dealing with the radius. Now, this is the bend radius. Now I'm going to use a smaller value. I'm going to say 0.1, and that's going to be the radius value that my corners are bent at. Next, we have to select bent edges. Now we have an option here to collect all bends. Now this is a very handy thing, but it really depends on what your end results are. If we say collect all bends, you see it says no pre-made bends were found, but you do have available options to create pre-made bends. We're going to talk about the manual selection process again because this is a basic series. We're not going into more advanced sections of sheet metal design. So under bent edges, we need to just start selecting edges where we want bends to be. So we're going to select all the bottom edges, and you'll notice that we'll start to get some previews on the screen. Let's go ahead and reverse the thickness. It might make a little bit more sense. Now if we view this, you can see that we have sheet metal sections coming away from our body. The corner we selected here has a gap. So it's bending from the bottom. It has a tear or a rip in the bottom, and it has a gap in the corner. So if we keep going along, we can select this edge, this edge, this edge, and the last one over here. Now what we've done is we've created a sheet metal part that starts at the base flange and it bends upward. We're basically creating a box. Now if you wanted to cap this or fill it off, you could select one of the top edges. You see that it gives you a sheet metal body that allows you to create a closed box. Now, of course, designing this in 3D in SolidWorks and actually physically making it are two very different things. This could be a very complicated box to make, and in reality, you would have to bend this edge early on, you'd have to press it into place and weld the seam. That's okay because we're not physically making this box. I just want to show you the process of converting it to sheet metal. There are some other options as we go down. We have corner defaults. You can change the way that corners are created. So if you modify these, you'll notice that it makes a change on the screen. we have an underlap, an open butt, or we have an overlap, it drastically changes how the corners are taken care of. So in this case, we're going to do an open butt. And you also notice that we have defaults for all gaps. If we want to make the gaps tighter, we can pull everything in a little bit closer. We also have an option for default overlap ratio. Now this is a percentage, this is 50%. If we reduce this, it'll tighten everything up. If we increase it, it'll push any overlaps. Now of course we're using an open butt, but if we use the underlap or overlap option, it'll change how close these sections are. For instance, if we go down to 0.25, you can see that it pushes them away. Now, the custom bend allowance, I want to talk briefly about this, but again, these are more advanced options when you're dealing with sheet metal parts. If you're making a sheet metal file and you're sending it off to a job shop, they typically don't care about your K factor or your bend table or bend calculations or any of that stuff. They really only want to see the final bent part, and then they'll take care of their own calculations in order to bend those corners. In most cases, not everywhere, but in most cases. Now, when you're talking about these factors, K factor, bend table, bend deduction, these all determine where the bend is in relation to the center line of the material. If you are bending things on your own, if you have your own brake, if you have your own tools in your shop to make these things, you're going to have to do some bends and play around with how far past 90 degrees, for instance, you need to make a bend that actually creates a 90-degree bend. And then you need to work with creating your own bend table. That'll allow you the information to create a more accurate finished sheet metal part. But again, this is really more of an advanced topic and we're not going to cover it here. The last section is auto relief. Now these relief types deal with the corners. So you'll notice in the bottom, we have a relief here to allow us to physically bend these up. If we had a sharp corner here, we would actually get a deformation of the material. We'd potentially get a rip or a tear that happens when you try to bend these. So you do have a couple different types of auto relief: tear, obround, and rectangular. Now it really depends on what your end result is going to be and what you want to do, but by default, it'll come on as a tear type. So once we've made all these selections, let's go ahead and say OK. So you notice that now we have a nice sheet metal part. If we do a section view, you can see that this is a complete bent sheet metal part. Go ahead and rotate this around. You can see that we have an open edge here and that we have our nice sheet metal part completely hollow. Because we didn't use the keep tool body option, we only have a single sheet metal part. We didn't keep the solid body that this was created from. But hopefully you can see how quick and easy it was for us to create the original extrudes and convert them to sheet metal with just really a few clicks. Now let's take a second to talk about how we would do this with a traditional bent sheet metal part. Well, we would start with the original sketch. Let's go ahead and expand the display pane, turn the original sketch on, and we're going to hide our sheet body. So in order to create this in a traditional fashion, we would take this original sketch and we would use it as a base flange or tab. Default 0.5 thickness, that's what we're going to use. You notice that we have, again, bend allowances, auto reliefs, and the current type of relief that's going to be used. We say OK, and what we've done is we've created a base part. Now what we have here is a base flat bottom of the sheet metal that we're going to create. From here, we need to do things like make bends, and we can sketch a bend, or we can do things like create edge flanges, and we can pull these up. We can tell if they're at a different angle, maybe 80 degrees. We can grab multiple edges at once, and we can determine how high they're going to go. In this case, the blind distance, 1 inch, and say OK. Now, if we need to carry on from here, we need to do a few more edge flanges, and this time, they're going to be at 10 degrees. And we can reverse the direction if we need to. And then again, collect the rest of our bends. So grabbing these inside edges, we can create all 4 vertical bends. Now, of course, we will have to modify the length. We will have to maybe modify the default radius value and determine where this bend is going to come in. If we're going to keep the trim inside, if we want to keep the corner restrained, or if we want to do completely outside of the original selection. Once we say OK, we can then cap off the top bend. Now, one thing you might start to notice here is that this looks a little bit different than the original part that we made. Because originally when we made this, we were able to quickly and easily create a bend that had gap consistencies all the way throughout the part. You notice with this one that these bends are going away from each other, and we'd have to come back in and make manual end treatments happen. So it's a very different process, and you can see the end result. We have gaps in a lot of different places. We would need to modify the profiles, modify the gaps in the corners. Or if we go back to the original part, it's a much cleaner version, and it was much easier for us to make because all the gaps are taken care of at the same time. Now we can flatten the part and take a look at what the result would be before we bend it. And we can export this data quickly and easily to get it to our job shop by going to Export, DXF, or DWG.